So this is ELC 131, Circuit Analysis 1, and today we're going to talk about resistors. Resistors are electrical components that are selected for their value of resistance, their ability to oppose current. Now, there's four major types of construction for resistors, and they are carbon composition, carbon film, metal film, and wire wound. Now, the carbon composition resistors have been in use really for well over 100 years. They were the predominant type of resistors used up through the 1970s probably. And they're formed by taking some powdered carbon, which is just like graphite in a pencil, and mixing it with some resin binders and some other materials such as clay to give us a resistive material that we could then connect two leads to and have an electrical component called a resistor. Now, there's a couple of things about carbon composition resistors. One is they're used because of they have an ability to withstand great surges of energy or great surges of voltage, and they're still used for that property. But one of the disadvantages with carbon composition resistors is that as they age, their resistance tends to increase. So it was found that carbon composition resistors just did not meet the tight tolerances required in modern electronic equipment. So they developed what's called a carbon film resistor. And a carbon film resistor is constructed by having a ceramic cylinder, and then they put a film of carbon around the outside of that cylinder, and then they etch away with a laser part of that carbon film, giving the component the desired value of resistance. It's really difficult to find carbon composition resistors today. The majority of the resistors that are manufactured and sold are carbon film and or metal film. Metal film resistor is constructed just like similar to the carbon film resistor in that you have a ceramic cylinder. It's coated with a layer of metal, and then part of that metal is cut away or etched away with a laser to give the component its desired value of resistance. And the fourth method of constructing resistors is with what's called a wire wound resistor. And a wire wound resistor is just a great length of wire wrapped around and around and around and around some ceramic core to give us a resistor that has very high power dissipation capability. Now, resistors come in several different form factors, and the most common one is what's called an axial lead, and here's a little pictorial of what an axial lead resistor looks like. And they call it that because the leads come out both ends, similar to the axles on a car. And let's take a look at an axial lead resistor. So you can see the axial lead resistor, the leads, of course, on both ends, and the body of the resistor here. And the value of the resistor is denoted with a series of colored bands, and we'll talk about that in just a few minutes. Now, if we look here, we can actually see the inside of a carbon composition resistor. You can see the carbon inside here, and then this epoxy coating around the outside. And you can see here on this end where the lead was before we broke it, so that we could see what was inside of there. Excuse me, and here's an example of a wire wound resistor. And we can see, of course, that it's just a long length of wire wrapped around and around and around and around some ceramic core. And again, these resistors are used for their ability to dissipate large amounts of power in the form of heat. Now here's another example of a wire wound resistor. And you can see this is a resistor designed to be able to dissipate 10 watts of power. And in this case, they've taken the wire wound resistor and put it inside a ceramic body, and then they've poured like epoxy here to be able to close this off to the environment. Now, resistors also come in what are called surface mount packages. Resistors can come in dual inline packages or a dip package, and resistors can also come in a single inline package or what's called a SIP. And if we look here, we can actually see some surface mount resistors. So this component right here, labeled R23, is a resistor. R22. And we look over here and there's another surface mount resistor, R18. So resistors also come in surface mount packages. This shows us an example of a dual inline package resistor. And they just look a lot like an integrated circuit like that we would have with our digital systems. But in this case, there's a resistance in between the leads. And resistors can also come in a single inline package, as we see in this example. Now, when we looked at the axial lead resistor, we noticed that the resistor had a series of colored bands around the body of the resistor. And these colored bands are used to denote the value of and the tolerance of the resistor. For our carbon composition and carbon film resistors, they're called 4-band resistors. And the way this works is these bands all have different colors, and each color corresponds to a different numeric value. So this band is the first significant digit. This band is the second significant digit. This band is the multiplier, and this band is the tolerance. We always start reading these bands from the end where the bands are closest to the end of the resistor. Now this is best explained by looking at an example. And let's just assume that these resistors are, this resistor has the following colored bands: blue, gray, red, and gold. So the blue and gray are the first two significant digits. Blue represents 6. Gray represents 8. And red represents 2. Now, this doesn't mean we take 6, 8 and multiply times 2. What this means is we multiply it times 10 raised to the second power. Now, the gold band is the tolerance, and a gold band signifies 5% tolerance. So this resistor would have a value of 6800 plus or minus 5%. which we will express as 6.8 k ohms, again, plus or minus 5%. We always want to express our values using correct engineering notation and preferred SI prefixes. So 6,800 should be recorded or expressed as 6.8 k. Now, what does this tolerance mean? It means that the manufacturer has guaranteed or stated that this resistor will fall within 5% of this named, or what's called the nominal value. So the 6.8 k ohms is the nominal value, and from here we can calculate the minimum and maximum range or permissible range for this resistor. So the maximum value will be 6.8 k ohms plus 6.8 k ohms times 0.05, and the minimum value will be 6.8 k ohms minus 6.8 k ohms times 0.05. So this is how we calculate the maximum and minimum values for this resistor, given in this case a 5% tolerance. Now, if the tolerance band is silver, that represents a 10% tolerance in the resistor value. Now, you may see some old electronic equipment where there was no tolerance band, and that would represent a 20% tolerance, but I'll be honest, I haven't seen a 20% tolerance resistor in the last 30 years. We're even hard-pressed today to buy a 10% tolerance resistor. The manufacturing procedures or quality is so good, 5% is the highest percentage I generally see. Now, what do we do in the case where we have a resistance that's less than 10 ohms? Because we're required to have two significant digits and a multiplier, and black can never be the first significant digit. So, in the case where we have resistances less than 10 ohms, for my multiplier, gold means times 10 to the negative first power, and silver means times 10 to the negative second power. So if we saw a resistor that was labeled yellow, orange, gold, and gold, this resistor would have a value of 4, 3 times 10 to the negative first plus or minus 5%. So this resistor would have a value of 4.3 ohms plus or minus 5%. So we use either a gold or silver multiplier in cases where the resistance is less than 10%. Now, with some metal film resistors, we can build resistors that have tolerances much smaller than 5%. So we can construct what we call precision resistors. Excuse me. Now, we have to use something besides gold or silver to denote the tolerance. So for precision resistors, a brown band represents plus or minus 1%, a red band plus or minus 2%, green, plus or minus 0.5%, and blue plus or minus 0.25%. Now, when we build resistors with this type of tolerance, we can now justify a fifth band. With a 5-band resistor, we couldn't really justify having a third significant digit because the range of values were so great that it didn't do me any good to build a resistor that was, say, for instance, 861 ohms, because the range of values were so great. But if I can build resistors with as close a tolerance as 0.5 or 0.25%, I can now justify a third significant digit. So when you find resistors that have 5 bands, understand that these are precision resistors with 3 significant digits, a multiplier, and a tolerance. So again, resistors are constructed either with carbon composition, carbon film, metal film, or wire wound resistors. They can come in configurations that are called axial leads, surface mount resistors, dual inline package resistors, and single inline packages. And we use a set of colored bands to denote the value and tolerance of axial lead resistors.